Today we will be utilizing the hub's built-in gyro sensor. This gyro sensor will measure 3 orientations. These orientations are yaw, pitch, and roll. Our focus today will be the yaw. The yaw is simply the left or right angle movement of the hub. This will be an important concept for us in today's lesson. Our goal will be to help our robot move completely straight utilizing the yaw feature. Let's get started. Open the Spike Prime software and select Spike Prime. Create a new project by clicking New Project. Type in yaw to name the project and click Python. Click Create. Start by highlighting line 7 and deleting. First we will initialize one of the motors on line 6. Type the following: motor equals motor, D. Now let's initialize the motor pairs. Type the following: motors equals motor pair, C, D. At this point we have initialized a motor and the motor pairs. Recall that the letters used represent the ports the motors are plugged into. Skip a few lines and add the following: hub, motion underscore sensor, reset underscore yaw underscore angle. This line of code will reset the yaw angle to 0 degrees. So when you set your robot down, the direction it is facing will be considered north, or 0 degrees. Let's add one more line of code. Type the following: motor.set underscore degrees underscore counted, 0. This line will reset the degree of motor D to a count of 0. This will be helpful since we will be counting degrees of this motor. Click Connect to connect your hub. Click the yellow play button to start the program. You will notice that the robot will not move. What we will do is inspect the yaw reading from the hub dashboard. To open the hub dashboard, simply click Hub icon. This is the hub dashboard and will provide us with useful information. As you can see, I have 3 motors plugged into ports B, C, and D. Focus your attention on the yaw reading. As you turn your robot to the left, notice the values get smaller. As you turn your robot to the right, the values become larger. As you turn the robot to its initial starting position, it gets closer to 0. Now that we know how to view readings from our dashboard, we will proceed to use these readings to keep our robot moving straight. Let's continue to add to our program. We will start with a while loop on line 14. A while loop will continue to run until a certain condition is met. Add the following to line 14. While motor.get underscore degrees underscore counted, less than 2000. This line will count the degrees of motor D and will continue to run the code below it, as long as it is less than 2000. Add the following to line 15. GSPK equals 5.3. Please note the indentation of this line. The GSPK is short for Gyro straight proportional constant. This is a value that will control how quickly corrections are made to the steering. This value will vary from robot to robot, so play around with this number and see what works best for you. Add the following to line 16. Steering equals int 0 hub motion underscore sensor dot get underscore yaw underscore angle GSPK. This line will provide instructions about the steering. In short, we are saying multiply the correction the robot needs to make by the GSPK value. We will also add the int to ensure the value is an integer. Add motors. Start, steering, 30, to line 17. The motors will start and use the value calculated from line 16 for its steering and will run the motors at 30%. Add motors. Stop, to line 19. This will stop the motors. Let's connect our hub to test it out. Before you hit the play button, let's consider what will happen. Once you place your robot down, the position it is facing is now considered due north. The robot will continue to move straight until it breaks from the while loop. As your robot is moving, try tapping it off course. Watch the robot correct itself and try to reorient itself back to moving straight. Awesome! Click the yellow play button to start program.